Hi, I'm Michael.
And I'm Justin.
And this is our podcast where we discuss what we find interesting about the intersection of Web3 and digital security as we know it.
Between us, we have years of experience securing digital products and infrastructure, which has led us to be constantly curious about what's next.
Which is what this podcast is about, sharing our journey as we update our mental models for security in the next internet.
Hello and welcome back to Not Your Crypto Podcast. Happy New Year from us. I hope everybody had a good New Year's break. This podcast is with me, Justin, obviously, and my partner, Michael. Michael, how are you?
Hello. I am good. New year. Snow on the ground. It's snowing right now, actually, as we speak.
That's nice.
So that's good vibes.
Yes. You are a big fan of winter, obviously.
I am. What can I say?
It's not snowing where I am. For our
why is
listeners.
that?
It's because I have now relocated. That's why I have now relocated to the Middle East. So instead of snowing, it's just now sand and 23 degrees of balmy sunshine.
That sounds like you prefer that, though.
No? I don't know. We'll see how it goes. It's a nice change from now because, like, obviously in Toronto, it's apparently going to get to minus 20. I'd rather not be around for that, so I'm glad I'm missing that. But I do like seasonal change. I'm a bit soft like that. So I probably can see myself missing the spring, summer, autumn, fall, as you say, winter changes. But I'm not mad to be in shorts right now. Let's put it like that. To our listeners, we apologize for the extended break. It was unplanned, but as I said, aforementioned move kind of took us away from all of our responsibilities, and we had to double down on other responsibilities. Obviously, Michael had a lot of family stuff as well. So yes, but we're back. We're back with a new episode, and we are building on our product focus as we were just before the break. What products are blockchain supported, blockchain enabled, and could only happen with blockchain technologies. And this is another one of those. We've nicknamed this podcast episode The Odd Couple, and you'll see why in a bit. But yes, this one is about a technology known as zkLogin or zero knowledge login. Michael, what do you think about zkLogin and what do you know about it? And let's go from there.
Sure. What do I know about it? Let's see. Let me scroll through the through the blog post again. Okay, so we started talking about zkLogin a while ago. Like, this was actually probably one of the first topics that we talked in depth about together, crypto related, right? I remember it was kind of early.
Yeah.
And okay, so like at a broad level, I think putting it in kind of like a product focused way, I guess. zkLogin is a would you call it a product? A feature?
It's a product feature. It's a product. I mean, it's a standalone product, but it's a feature that you attach onto your own product. Okay. Similar to, well, actually, sure. One of its components, OAuth, right? Is OAuth a product?
Yeah.
Or is it a protocol?
Service, protocol, whatever.
Yeah.
It's so zkLogin, let's say, is a product that allows you to interact with a blockchain using a OAuth sign-in as your identity.
Basically. Yeah, that's kind of it.
And this makes me think back to, we had that episode talking about identity, like your identity on the chain, which we'll talk about, probably reference some more as we get going.
Yeah.
But there, the focus was like, what's your identity? Your identity is a key, right? Was kind of the 1 second summary of that episode.
Basically, that is it. Yeah.
But here it's not kind of, I guess, is the answer. Here, in a way, your identity, particularly from the user's perspective, like as somebody who's using a distributed application or who's using a product on the blockchain, your identity is the same as your identity is in Web2 world that you're familiar with.
Yeah.
It's logging in with an account.
Yeah.
And there's a whole set of protocol magic that happens to make that work, which is the interesting kind of technical details here.
Yeah.
Because like at the end of the day, the identity still is a key, but there's a lot of magic that happens in between the kind of sign in and the transaction issuance or whatever.
Yeah. Transaction signing,
that makes that happen. Okay. Yeah. I don't know. Did I get there? Did
I say what it is? And that's kind of why we decided to call this The Odd Couple, because we have two concepts here. We have OAuth login and OAuth authentication protocol, which is a separate Web 2.0 protocol, which all of our listeners will be familiar with but don't know what it is, i.e., they've used it all the time. Basically, your social login. If you use your Facebook or your Twitch account or your Twitter account to log into a service that isn't being presented by them. So, for example, I think booking.com allows you to log in via Google. That is basically OAuth in action. It means you don't have to create new usernames and passwords for every service. And there's a bunch of other advantages you get with it. So that is a distinctly Web 2.0 technology. And then you have this concept of zero knowledge. Zero knowledge is a very fancy term for a very complicated cryptographic protocol, which allows you to do some cool things. And what's happened is with this zkLogin product, they've used zero knowledge to basically abstract away the need to create wallets every time you go on the chain. Okay, I've just said a lot. Any of our users who have interacted with any distributed apps, i.e., applications or decentralized apps, i.e., applications that are blockchain centric or blockchain native, will know that in order to play any game, or as in order to engage with them, you have to create this thing called a wallet, which is kind of what Michael's hinting at there. And a wallet is an abstraction in of yourself. It hosts your identity mechanism and your authentication mechanism, which we discussed in a previous episode, which is a new way of doing things. It collapses them into one abstraction. And so with that, this is a new learning. This is a new paradigm. If you're used to username, login, and then just going into an app which is hosted by Meta or some other centralized service, you don't need to worry about all of this. Whereas on a blockchain, which obviously everything is decentralized, when you have this concept of a wallet, it's now just a new thing, a new component you have to get your head around. So that, in some people's eyes in the blockchain world, can be seen as onboarding friction. And so in steps zkLogin, where it's like, okay, if people are used to the username password paradigm of logging into things, how about we give them that back? And then also they don't need to worry about a wallet. Why would anyone need to worry about wallet? I hear you scream. Well, again, if you've had minimal interaction with the blockchain, your wallet is an abstraction for public-private key pair. It's cryptography. Yay. And key management. Yay. And any of our security engineers who listen to this podcast knows key management is the bane of every security professional's, even compliance professionals' lives at some level. It always comes down to keys. The moment you implement cryptography, it's key management. That's where you shift the security boundary, Michael's trademark phrase, to. And so with wallets, you basically give the user the key management problem. So again, zkLogin stepped in to say, how about we abstract that? So we abstract the keys, we extract the wallet away from the user and give them the old paradigm they're used to, so that they can still engage with decentralized apps, but they don't need to worry or faff around with all that cryptography and stuff. And ta-da, zkLogin was born.
Yeah, I think like what's like interesting to me about that, right? If we talk about identity on a blockchain, the typical discussion is around custodial and non-custodial, right?
Agreed.
So like, I either have like a non-custodial wallet, which means like the identity, going back to that other episode, the identity is like client centric, right? Like I, as the user, have the key and I control the key and I use the key and manage it and all that. Mm-hmm. Did I use the right words? Which one did I say that was?
Sorry, I actually
did I say non-custodial?
Non-custodial is when it's centralized. Yeah. No, sorry. Non-custodial is when you own the keys. Sorry.
Yes,
wow.
Okay. Anyways, there's non-custodial identity, and then the other one we're familiar with is custodial identity, which is I actually don't manage the key at all. I've offloaded that responsibility completely to a service.
Yeah, Coinbase.
Like Coinbase, or others. There's like lots of ways to do that. And so they have a key for me in some sense, through some backend management, and I log into them the way I'm used to, username and password, and hopefully MFA. Yeah. And then my interaction with the blockchain is then mediated through that centralized service. Yeah. So there's those two things. What's interesting to me about this like zkLogin stuff, and one of the reasons why the brain like spins on it, for me at least, is this feels to me like genuinely a third thing. Mm-hmm. You know what I mean? Like it feels to me like a kind of, it's not on that spectrum so much. Mm-hmm. Like it's not one of those two kind of polarized product decisions or like user decisions, I guess. It is genuinely like a third way to interact between your identity as a client and the blockchain. Like
Agreed.
and that's neat. Like
Yeah.
that's interesting to think about, and it's
Yeah.
interesting to think about. Okay, like if this is, because there's a lot of like, at this point, a little bit tired discussion around the different trade-offs between custodial and non-custodial wallets, right? And it's basically, oh, well, it's easier to use a custodial one because you just log in. Oh, but then you don't have the key, not your crypto, like that, like that whole
Yeah.
dialectic or whatever.
Yeah, exactly.
I like this because it kind of, to me, genuinely injects something new into that discussion. Like,
1,000,000%.
what about this way, right? Like,
Yeah.
what are the trade-offs with this?
Yeah.
They're different, right? Like think about that. Yeah.
Agreed, and that's what kind of got me excited about this as well as the the technical implementation of this brand new tech, which obviously both you and I kind of get stimulated by. Anyway, we're like, oh, new shiny tech, new weird things, and that's the zero knowledge thing. Although to this day, neither of us can still understand it completely.
Yeah. That's the other thing I wanted to just like briefly mention. Like in one of our other episodes, I talked a little bit about how like in crypto, there's all these different kind of like flashes of a approach or a technology that feel like they shouldn't exist, but that do exist. You know what I mean?
Yes.
Do you remember this?
Yeah, I do remember that statement.
And how like public key cryptography is one of those things. Like it just kind of feels like that shouldn't exist, but it does.
Yeah,
right?
It does. Exactly.
There were some other examples we talked about, but zero knowledge proofs are another one of those things where you
1,000,000%.
You hear about them and you're like, that feels like it shouldn't exist, but then it does.
It does.
And you can build things with it.
Any technology sufficiently advanced enough feels like magic, or is close enough to
indistinguishable from magic or whatever.
There we go. And that's exactly what I feel like with zero knowledge proofs. The more and more I read about it, the more I'm like, I don't understand how. So let's talk a little. Let's get in. That segues us into the details, and then from there we'll get into a little bit a sidebar into zero knowledge proofs. But so the real question is, how does this work? Long story short, as I said, we've called this the long old couple because it basically integrates two separate pieces of technology. You have OAuth, and then you actually have zero knowledge proofs. So what this allows you to do is, as I said, it's an abstraction away from the creation of wallets. So from an outsider's perspective, as a user, you effectively choose your social login provider. Again, Google, Twitch, Twitter, Facebook, whoever you like. The app will choose which provider they're. zkLogin supports a bunch of different providers, but your decentralized app will say, would you log in with your OAuth provider? You then choose whichever one makes sense, which are from their shortlist. If you go on the zkLogin page, it actually tells you which ones are actually integrated into their zkLogin code base at the moment. So you then log in, and then in the background is where all the magic happens. Because long story short, there is a third-party intermediary between Web2 world and Web3, and that is the SALT service. So what this SALT service does is it takes the JWT, or the JOT as it's known in technical parlance. It takes the token that is given to you by your identity provider, which is your social login provider, again, Google, Twitch, Twitter, or whatever. They give you a specific token. And this is a normal OAuth flow, by the way. They give you a token that then gets sent to the app, and that's what authenticates you to whatever app, normally in Web 2.0 world. So again, just for those following along, booking.com, you log in with Facebook. Basically, you log in via Facebook, your username and password gets sent to Facebook, that gets authenticated, it gives you a token, that gets sent to booking.com. Obviously, Michael, keep me honest here. And booking.com says, yes, through the magic of cryptography, this is a valid credential. You're now logged in via booking.com.
Basically, it's signed by Meta or Facebook. Basically. And that's how it knows that it's legitimate, even though that token may get to the service through you, right?
Through you, because it's redirected through your browser. Instead of going to booking.com, what happens here is it goes via the decentralized app, goes to this thing called a SALT service. Then through some more cryptographic magic, this SALT service creates another credential, and it's through these credentials that this wallet address, I'm now introducing another word, addressed. Wallets in blockchain have addresses. You need an address to interact with the blockchain. It's a point of identity. So this is another deep cut callback to our other episode where we talked about identity. So wallets don't just have your private keys, they also have your identity, which is an address, and you need an address to interact with anything on blockchain, because everything has an address on blockchain. You need to know what you're talking to, transferring to, and things from exactly. So what happens is once you've got this credential from this salt service, by the way, is hosted by the company that has set up this protocol. Michael, you look like you want to say something.
Yeah. Well, I think there's different options for what the salt service is like.
Okay, cool.
One option is that you use a hosted salt service that, which the company runs, obviously to help with adoption, or so that's there, best practice, all that kind of stuff. There are other setups for the salt service which have different trade-offs, which we either can or can get into, depending.
We can get into a second.
But I think typically when I think of this implementation, I also think using the hosted salt service that's run by the company. Yeah.
Yes. And there's reasons why I'm biased towards that with the security question in mind. And we'll get to that definitely, because there are some random minor points of security risks around salt services. Anyway, it gives you a credential. And then using zero knowledge proofs, or zero knowledge magic, as we like to call it, you then derive an address, which is permanently tied to your OAuth credentials, your identity, and a key pair, public-private key pair that we initially said would normally be created, which is a wallet. Sorry, your wallet would abstract away from you under normal circumstances if you weren't using this anyway. The public-private key pair in this instance, though, is ephemeral, i.e. they disappear after a period of time. And they are all derived magically from you just logging in and getting this JWT token that is sent to the app. This magic is zero knowledge proofs. I'm not going to get Michael to explain zero knowledge proofs other than...
Thank you.
Zero knowledge proofs are called zero knowledge proofs because, and let me just check my notes to make sure. It's basically a privacy mechanism. It's a privacy protocol underneath it. And it basically allows two untrusted parties to verify that they know the same piece of information to each other without revealing what that information is. So in this instance, the derivation from the user salt and the OAuth credentials, basically, once you've already set this service up to interact with a decentralized app, there should never be a need for the salt service and the OAuth creds to be swapped between the two of them. They use zero knowledge proofs. It allows the app to derive an address, an ephemeral key pair. That is my understanding. Now, the positives of this, you might be wondering, why would I do this? Why wouldn't I just go through a wallet? Well, again, there's a bunch of reasons why they decided to come up with this product. One being user onboarding. So it's a UX experience, UX concerns mainly. Another reason why I think this product has the raison d'etre basically for this product is the decoupling that we were talking about earlier as well. So while it's collapsed identity and authentication into one abstract entity, they've now decoupled it. Because obviously, as we mentioned earlier, the official terminology for your social login provider is an identity provider. That's what these Googles, Twitches, Twitters, etc. logins do. They provide an identity to another application. With zkLogin, they've kind of decoupled it again. So the ephemeral the keys that you need to authenticate transactions on blockchain are separated out from the identity. Your address is almost, we don't know yet. We haven't seen an instance whether it's actually visible to you. It may be visible to you, but it's no longer your identity to you. And more importantly, it's not recorded on chain either. And so that's a privacy mechanism that they've implemented there, which I do also have some thoughts about. But overall, that's my understanding of the problems that this product is aiming to solve, and how they've taken a very innovative approach, in my opinion, by basically integrating two separate technologies, one very distinctly Web3, the other very distinctly Web2. So that is how, basically, maybe a mangled overview of how it works and why it exists. Michael, so with that, I'm going to hand over to you and ask you, what are your thoughts on this?
Yeah, I think it's like, when you look at it, I think, kind of going back a little bit to what we were just saying before, it's like thinking through, okay, what are the trade-offs that this thing is making in the design to achieve its objectives, right? Like its objective is that you log in through OAuth. So what are the implications of that on the security side and on the privacy side as well, I guess, with the whole design around the like proving structure. And so, probably the first thing somebody's mind goes to when you hear about this is, okay, what happens if the OAuth account is compromised, right? That's one thing. Another thing is probably what happens if like access to the OAuth account is lost. And I think there's a few different ways it could be lost. It could be lost by the user. It could also be lost by the OAuth service, either in some like one-off thing where somehow it loses. I don't know, lose your. I don't know if I've ever heard of that happening, but somehow loses your account, or the OAuth service isn't available, or the OAuth service shuts down. Right. Especially as you like expand the number of supported providers past things that you would maybe just assume will forever and always be there, like Google and Meta and whatever. So yeah, I think those are like the most immediate things to think through about it. I think there's also a question of like comparatively, how it does this compare. If I'm a user of this, I'm like a client of this, just a user of zkLogin on the blockchain, or just a user of the blockchain. You can also think about it comparatively, like how do those trade-offs compare to the trade-offs I make when I have custody over my own wallet? Because there's also ways that you can lose stuff there, or ways that stuff can be compromised there.
Welcome back to some of our listeners. We've had some technical issues, so the cut of this podcast may sound a bit weird, but that'll be why.
What trade-offs is the design making that have an impact on the security, particularly the security for a user of this system, and particularly maybe for the security of a like less sophisticated user, like a user who is not as proficient, I guess, at securing their stuff, right? So I think there's a few areas to think about with that. One kind of area of it focuses on like the OAuth login itself, and what that means for the security of this overall kind of solution. And then I think there's another area of discussion around like the salt and the salting and what that has, what configurations that can be in, and what impact that has on it.
1,000,000%. And for those, sorry to cut you, those that obviously can't see and listen to this audio, I am nodding vigorously because that's where that was where my spider senses went up, was the configuration of the salt service. But yes, carry on.
Yeah, for sure. But okay, so here, actually, you know what? Let's start this off with a question. Let's change it up. Let's start this off. I'm going to start this off with a question to you.
Yeah, go on.
Do you think for, let's say, a person who's coming into this fresh, like new-ish to blockchain and crypto, not really concerned with the security elements of it, is just wanting to use a product, like wanting to use some DApp product. Do you think that on average, this would be more or less secure for them to use like a zkLogin than for them to use some custodial, than for them to have a key to have custody of a key themselves on their computer, in some app on their computer?
1,000,000%. This is more.
You think this is more secure?
Yes, because so this is where we get into. This is a really good question. Let me get on my soapbox, because this is where we get into your whole security boundaries thing that we keep talking about over and over. So basically what you're doing here is you're outsourcing the security of your credentials to the identity providers. Again, for those that have been following along, that's your Twitch, Meta, who else? Twitter, Google, all of those. I am betting that their security posture is basically more robust than individual end user on their one random laptop. People can't even keep passwords secure. So I actually think that, given the power that a public-private key pair has in a blockchain setting, I think it's 1,000,000% more. I like the advantages are exponential to my mind. It's from a security perspective, also from a UX perspective. But I'll keep my answer short. But yes,
do you think that's true? Do you think that's true about like phishing and stuff as well as attack vectors?
Okay, so phishing for attack vectors to then retrieve no, I don't think it's more secure. I do think, because at the end of the day, phishing is just basically you receiving an email, then someone being able to infer your email address somehow, and then asking you to do silly things and give up the password. No, it's not more secure. But then I think all logins have the same risk. I don't think zkLogin increases your risk, or what's the word? Your propensity, not even the propensity, the potential exposure you have to that risk anyway. I don't think use of zkLogin increases or decreases that anyway. You have that whether you have a social login or not. Does that make sense as an answer?
Yeah, I think it does.
What do you think?
I don't know. That's why I asked you. I think I think it's different. I think that in terms of, if you think about like where is a raw credential being stored, and in the one case a raw credential is being stored like, in some hopefully encrypted file on disk on your laptop, basically. And in the other case the raw credential is being stored in an OAuth provider, let's say, then I think that for sure what you're saying makes sense. That, obviously the OAuth provider should be more trusted. It is likely more trusted in that circumstance, particularly if you're a, first time user of these things. From a from that perspective I agree. From the perspective of like, I'm a target, let's say I'm a target of some phishing thing or whatever, am I more likely to have my OAuth credentials phished in a way that like causes a problem for this, versus am I more likely to be subject to a different kind of phishing thing that gets my seed phrase, or that, there's like phishing transactions and stuff as well, which is, I think, something we're interested in talking in other episodes.
Yeah, definitely.
That I don't know.
Yeah.
I don't have a good gut for that, because those are like different sort of phishing campaigns. One's like much more familiar to users than others, and so I'm not sure which way that would swing. So yeah, but it's interesting, right?
It is interesting, and it also there's an irony to this as well, because there's the security and then there's the privacy. One of the things that blockchain technologies, one of the things they like to say or they like to prove is about censorship resistance, which is also a tangent of privacy. It's an outgrowth of privacy, really. And one thing that did kind of as an amber flag for me is the idea that, okay, all of these centralized, because all of these OAuth providers are centralized business entities, end of story. They will now be able to track your interactions.
Could you? Interesting. I wonder if that has to be the case, but that's a different topic. Keep going.
Well, here's the thing. I don't know, because I'm not an OAuth professional, but is there a way that they can disregard or basically obfuscate, or is it possible to obfuscate the application that you're logging into when you do authenticate to your OAuth provider? Because what I'm trying to
sorry, go ahead. With what you're thinking about.
For the sake of the listeners, is basically, long story short, Google and Meta can track which apps you log into. And
like if I'm using a distributed crypto blockchain app,
they'll be able
the OAuth provider knows the fact that I am using that app, though what the protocol is designed for them to not know is what my identity is inside of that app, right?
Exactly that. And so I think there's an interesting conversation to be had around privacy around that. We won't go into it too depth because we are conscious of time. But that was one thing that triggered. And then the other thing is this salt service, the intermediary that basically gives you, that basically authenticates you to the blockchain.
It's what breaks the link, right? It's the part of the protocol that breaks the link between the authentication and the identity, right?
Exactly. It breaks the link, but it's still a centralized service in terms of how it is set up.
Well, I think this is the interesting part, maybe. We talked that there's different configurations the salt service can be in, right? One, and I think the different, one set of configurations the salt service can be in is there's some centralized service that's, you query and say, I have this identity, give me the salt, and it gives you the salt, right? And that can either be based on like it keeping some kind of, hash table or database kind of thing, or it can be algorithmically derived. So it can either have a data store of the salts or cannot, which is also, those are two different threat models. Those are two different threat models, essentially. The other option is for the salt to be kept client side, which is another set of configuration this can be in. So like, either you tell the user, here's your salt, you need to store it somehow, or it gets stored like within I guess within the application essentially, or like within the browser, or within the like application that you're using.
Yeah, I'm assuming within the app.
Which is a different kind of set of security trade-offs there. And much more like I'm asking the user to store a seed phrase, or I'm asking the user to be responsible for a key. But yes, I don't know, like in terms of the different applications using this protocol, I actually don't know what the landscape there looks like. I would assume that most are using the service kind of thing, right?
I have a feeling, I mean, if you're a dev and you want to get this thing out the door,
you're just gonna hook into the API, right?
Basically, I imagine that.
There's a nice library that you download.
Like, what am I doing here? Like, library, scan it.
You got to do whatever Claude tells you to do with it. So we'll just ask and see.
AI jokes, love it. Yeah, exactly that. And so I do think that again, I'm starting to feel like we're laying out the land of crypto in terms of from a security theory of risk around security, because we've discussed this again. Centralization, decentralization exists in the continuum, and it's basically where do you want to go on that continuum in order to optimize for UX, in order to optimize for a good enough security model compared to the rest. So this is at security, convenience, and speed. I think it is, right? It's just that triangle, and you're just operating somewhere in between that matrix. And I think again we've kind of bumped into that with this. And overall, though, I think this is a fantastic idea and a fantastic product, and that solves a lot of good problems. But again, if you were to ask me specifically about, so for example, do I have any privacy concerns? Yes, there would be. Do I have any concerns around the idea of this intermediary? How decentralized and centralized is it, and therefore what are the consequences of that decision or that implementation? Again, I would have some points to raise, but that's kind of where I'm at with it, to be honest. What about you?
I agree. I think like also when you think about looking at this, thinking about what do I care about? Like, do I care about the security of the login, or do I actually really also care about the privacy preserving features of it? Because those are very different. Like, they get bundled together, but in terms of what you can compromise to make different trade-offs, those are two very different spaces. And products would legitimately care about one much more than the other. I mean, as a baseline, you would care about the authentication login regardless. The other aspect that I'll mention about this in kind of a final thought that I haven't fully thought through, but that was interesting to me, is like the whole idea that now the distributed application,
decentralized, you mean? Sorry,
decentralized application. Yeah, the D, I don't know. Yeah. I don't know the actual words. One of the kind of neat things of this setup that I haven't fully thought through the implications of is that the ephemeral key pair, right?
Yep.
And the fact that it is ephemeral, it has a timeout, right? So this starts to feel a lot like, actually in OAuth, it starts to feel a lot like having like a refresh token and a session token, right?
Yes.
And in OAuth, like a lot of times the refresh token and the session token, they kind of collapse into the same thing because they're like stored in the same place. They have the same kind of access. It feels a bit like, well, why is there this distinction or whatever? Because like, the threat model between the two is very similar.
Very similar, yeah.
But in this case, it's not, right?
No.
Like in a way, the application has the ephemeral key pair with the timeout that it gets through the OAuth flow. And then the actual, like what is like the session token equivalent, which is the static key pair, like the actual identity key pair, is not accessible to it, right? Like that's part of the whole zero knowledge proof kind of chain.
Yes, it is.
So this is interesting because it does have this kind of refresh session thing in the ephemeral key pair and the identity key pair. But they actually have different threat models, really, like substantially different threat models, and that feels like an improvement to me. Like that feels like it does something important for security, 100%. Particularly for security as a user who's running applications that may be compromised, may have supply chain issues, may maybe malware on my computer, whatever. Like that feels like the kind of thing where it makes a difference. So that's a neat part of it as well, I think.
That is a very neat part, and I never thought of it like that. But when you frame it like that, because the amount of times I've been on, you and I have either assessed an application and the refresh token basically has the same rights as the actual authentication token, and
Yeah.
you're like, well, okay, that's not supposed to be the case anyway. But more importantly, what it does is it leaves the decision up to the application maker, the applicant, the dev in that case. Whereas within this, with zkLogin, this comes out of the box, and you can configure the timeouts for the ephemeral key pair. But the point is, the separation of the identity and the authentication comes as standard out of the box. So you do have the idea of the refresh token is separate to the actual.
Or imagine something that takes it even farther. Imagine something that makes it a one-use token, right?
Yeah.
So instead of being like a refresh token, we should use the actual terms. So being an ephemeral key pair with a timeout.
Yeah.
Imagine it's a one-time use key pair somehow. Yeah. I don't know. Maybe you could just hack that with a very short timeout. Maybe there's a way to make it actually one-time use. I don't know.
Yeah, there probably is.
And then imagine my OAuth credentials are tied to something like are tied into my keychain somehow, or are tied to like a why am I forgetting this word? Key pass? What's it called? Passkey. Oh my gosh.
Passkey, yeah, it's okay.
Imagine it's tied to a passkey or something, where I do need to actually like FIDO authenticate to a kind of TPM sort of thing to have the transaction go through. Yeah. That's starting to look like a very tight security model, I think. Which is neat.
Have you just given birth to a new product on the podcast?
I don't know, dude.
I think you have.
I'm just the ideas guy. I can't actually do that. If Claude can't do it, I won't be able to do it.
Okay, well, I'll be going on to Claude tonight. Okay, I think that brings us up to time. This was a great podcast. Apologies for any of the technical issues we've got. And Michael obviously has a cold. He's got a bit of phlegm in his throat as well.
It's been
if that comes across
for weeks. I don't know. Has this gone through your place? It's been brutal.
No,
like everybody's sick just forever. Yeah.
Oh, wow. No, yeah. I managed to escape that. I got lucky. All right. Thank you for listening. And we will be back. Apologies for the delay. There are going to be sporadic releases as I get settled in my new home. But yes, we have more episodes on the way. So please be on the lookout wherever you get your podcasts.